Hello viewers, today we will discuss two definitions. First, Maxwell law of reciprocal deflection and second is relative stiffness. Maxwell law of reciprocal deflection. When a linearly elastic structure is in static equilibrium, the displacement at a point P due to a force applied at Q is equal to the displacement at the point Q due to the sum force A applied at P, shown by figure. This is a deflection delta PQ. Suppose this is load at point Q, this A, this one is B. So the displacement at a point P, this due to force applied at Q, this is force applied is W at point Q is equal to the displacement at the point Q due to the same force A applied at point P, shown in another diagram. How? This deflection delta Q P P. Now understand, the displacement at a point P due to force applied at Q, okay, is equal to the displacement at the point Q due to the same force A applied at P. Same force applied, this W, and in this side and this side. So deflection Q delta PQ, this delta PQ is equal to deflection delta QP. So this process is known as Maxwell law of reciprocal deflection, and other is relative stiffness. So what is relative stiffness? For example, this is a fixed beam and this rolling half UDL act, any point load, total distance is length 2.5, this is 1 by 5 moment of inertia of this beam, and this is a length 1 upon 2.5, this, okay. So what is relative stiffness? The ratio of I upon L, where I is moment of inertia to the length of span, L is length of span, is known as relative stiffness, and it is denoted by K. Okay, so what is I? I is given 1 by 5 upon, and what is length of span? The total length of span is 2.5. So this is your relative stiffness of this beam. One side is fixed and other is supported, rolling support. That's it.